In our last video, we talked about different types of energy, renewable and non-renewable. And so today we're going to take a deeper look into the non-renewable energy sources. So our non-renewable energy sources are called fossil fuels. So fossil fuels are made from plants and animals that lived hundreds of millions of years ago. So in order for this to happen, the plants and animals had to die, and then their remains settle into the ground and or the bottom of the sea. And so over time, layers upon layers stack up, and they start to compact the layers below them. More and more layers will increase the heat and pressure below them. And so over millions of years, the organic material turns into fossil fuels. And so these fossil fuels are made up of hydrocarbons, and hydrocarbons are fossil fuel compounds that are made up of carbon and hydrogen. And so these can be found in the three different states of matter: solid, liquid, and gas. Solid hydrocarbons are called coal. Liquid is called petroleum. Sometimes it's called crude oil. And the last state, the gaseous state, is called natural gas. So we're going to take a deeper look at each of those three forms: coal, oil, and natural gas. So coal forms from dead plants, and that settle to the bottom of swamps. Water and mud from the swamp keep oxygen away from the plant material, and then sand and clay will settle on top of it. The weight of the sand and clay will compact that dead plant material, and over time, the organic material will become a carbon-rich rock. So it's got a lot of carbon in it, and we call that coal. So coal can be black to brownish black, and it's a rock, and it burns easily. Most different types of coal is classified as a sedimentary rock. However, a type of coal called anthracitic coal is a metamorphic rock. And anthracitic coal contains the most energy. It will burn the most efficiently of all the different types of coal. So here it's just important to notice that there's different types of coal. So anthracitic coal forms because it's exposed to higher temperatures and pressures as it forms, and that kind of makes sense because high temperature and pressure is a good indicator of a metamorphic rock. It's composed of mostly carbon. However, some types of coal may also contain sulfur. And so when I said that there are different types of coal, it has to do with the amount of sulfur in them. Anthracitic coal has almost no sulfur, and that's why it burns the most efficient out of all the different types of coal. So when we get coal, we have to mine it. Around the world, coal is the largest source of energy for electricity. And so in the United States, electricity. In the United States, it actually has a lot of coal over in Pennsylvania and west of the Appalachian Mountains. So here's a map of your Appalachian Mountains, and anything to the west of it, there's a pretty good coal deposit. It needs to be mined out of the ground in order for it to be used, and it can be done by either surface mining or underground mining. So the surface mining exposes minerals that were underground to air and water at the surface, and those minerals can contain the element sulfur. Sulfur combines with air and water to make something called sulfuric acid. And sulfuric acid is highly corrosive, means that it eats away at substances. So if we were to touch sulfuric acid, it would start to make your skin tingle, and it would actually start to break down your skin. And so sulfuric acid, because of this corrosive property, kills fish, plants, and animals. And so we prefer not to expose sulfur into the atmosphere. Underground mining, we know, is dangerous for the humans involved because the mines can explode or collapse, and especially when you breathe in coal dust, it can cause a lung disease. I believe it's called black lung. And it basically coats the inside of your lung with all this coal dust, and it doesn't allow your lungs to expand to their full capability, and so it makes it very hard to breathe. So in order for us to use coal to make electricity, it first needs to be crushed into a powder, and then we actually burn it in a furnace. This releases most of its energy as heat when it gets burned. So the heat from the burning of the coal boils water. This makes steam. We know boiling water makes steam, and then that steam is used to spin turbines in order to create electricity. And so this process here, I mean, except the first part of crushing and burning the coal, it's basically we burn something to boil water. The boiling water makes steam, and the steam turns a turbine, and that creates electricity. This process to make electricity is used regardless of burning coal or natural gas. So oil is a thick, again, it's dark brownish black liquid, and it's found in rock layers in Earth's crust, and it's a commonly used source of energy throughout the world. And so, again, it forms by plankton and algae dying. Plankton are little, they're almost microscopic creatures in the ocean. And they die and settle to the bottom of the ocean. And then sediments from the ocean will settle over that dead organic matter, again preventing the oxygen from reaching the material. If the oxygen were to reach the material, the oxygen would just decay the material, the remains, and it wouldn't be there to make oil or coal. So when it's buried deep enough, it's exposed to high temperature and pressure. And then over millions of years, the organic material will transform into liquid oil. So just like coal, oil needs to be mined. And so the United States produces about a quarter as much oil as it uses. A lot of our oil is found in the Gulf of Mexico, Texas, Alaska, and California. And so in order to find it, geologists look for a folded layer in the rocks, and we call that an anticline. And if you find an anticline in these regions, it is a good indicator that there could potentially be oil there. Oil has the ability to move through rock if the rock is permeable, meaning it has some type of holes in it. And then that oil will get trapped by impermeable, and we call that a cap rock because it's not able to move. So this is an oil refinery process, and so we can talk about that here. So oil directly out of the ground is called crude oil. This is a mixture of many different hydrocarbons. I kind of think of this as like dirty oil. and it's just mixed with a whole bunch of different hydrocarbons. And so it has to be refined in an oil refinery, and it gets separated into those different hydrocarbons by heating this crude oil. So each of these hydrocarbons listed right here, they all boil at different temperatures, and so this allows us to separate them out. So in crude oil, we can get gasoline, diesel, heating oil, waxes, plastics, and fertilizers, but we need to separate them out from that crude oil. So rich energy sources, these are the rich energy sources in crude oil. They have a lot of energy and they are easily transported. They provide about 90% of the energy used for transportation around the world. So a specific one that we use frequently is gasoline. This is a concentrated resource, meaning it has a lot of energy in a very small package. It doesn't take a lot of gas to be able to power a lot. This is a very practical fuel to power our cars and other forms of transportation. So it works by when we burn the gasoline, and it releases most of its energy as heat. It also will release carbon dioxide and water vapor. So the heat makes the gas expand, and that forces the pistons inside the engine to move. And then the engine makes enough power to move the car. So we need these pistons to move in order to move the car. It's kind of a cause and effect, or a domino effect situation. So using oil and gasoline will affect the environment. We know by now that exhaust fumes cause air pollution. It can create smog and ground level ozone. And these two things are bad to breathe in, and they can cause other problems. They're mostly problematic for cities where there's lots of driving. And perhaps the biggest problem of all is the production of carbon dioxide. So CO2 is carbon dioxide. And this is what we call a greenhouse gas. And this greenhouse gas traps heat in our atmosphere and is a big contributor to climate change. And we've got a whole chapter on that. So natural gas is our third type of fossil fuel. So it's mostly composed of methane, and methane is a hydrocarbon of CH4. And it's found near or by coal or oil underground, and it forms with fossil fuels. Natural gas forms at higher temperatures than other fossil fuels because remember, it is a gas, and so it needs to just like water vapor forms at higher temperatures. Think of when you boil water, that steam or that water vapor doesn't start to be produced until the temperature is high enough. So what do we use natural gas for? The largest gas reserves in the United States is in the Rocky Mountain states, so over by like Wyoming and Montana. And it's also found in Texas, the Gulf of Mexico region, and in Northern California. Just like crude oil, it has to be processed before it can be used because there are poisonous chemicals, and the water has to be taken out of the natural gas. Then natural gas can be delivered to homes for cooking as well as heating. So in order to use it, it powers the turbines to make electricity, releases most of its energy as heat when burned. Remember, this process I told you was going to be used many, many times. The heat is used to form hot gases or steam to spin turbines, and the spinning turbines generates or creates electricity. So using natural gas it has negative effects on the environment to process it. However, it does burn cleaner than other fossil fuels because we take out so many things in the processing of it. It causes less air pollution when we burn natural gas. It produces less carbon dioxide, CO2, than other fossil fuels. However, it still produces some pollutants. So, problems with fossil fuels, there's a lot of problems. First of all, they're non renewable resources, so our supplies will eventually run out. So, we will run out, probably even in your lifetime. So there's some safety concerns. So we've heard of gas leaks in neighborhoods and communities. It's high. Natural gas is highly flammable, so it could lead to an explosion. With all the mining, there's some environmental concerns, as well as when we burn these fossil fuels, the release of carbon dioxide and the sulfuric acid are some major concerns. And acid. And here we talk about the carbon dioxide. Coal has the highest environmental concerns out of all of these fossil fuels because it releases the most carbon dioxide. It's also the most common fossil fuel, and it is the biggest contributor to climate change. And then this sulfuric acid can right here, causes acid rain. So that again is also a big problem because it can be deadly to plants and animals and even whole ecosystems. Burning coal also releases small solid particles into the air, which are dangerous to breathe. So another type of natural or non-renewable energy is nuclear energy. So we get nuclear energy. We use uranium, and they take a whole bunch of uranium and they shove it into a concentrated fuel rod. Sometimes they're called fuel cells. And if any of you watch The Simpsons, in their opening song or credits, when Homer's running around with that green rod, that would be a uranium rod cell, fuel cell. And so we get the energy out of that uranium by splitting the nucleus of that atom. And they're split apart when they're hit by these extremely tiny particles. And these tiny particles have to be controlled or there will be an explosion. So nuclear power plants use the energy produced from this splitting of the atoms to heat water. The water turns to steam. The steam causes the turbine to spin, and the spinning turbine creates energy. So now I think this is about the third or fourth time in this video we've talked about this process. And the only thing that changes is how or what we heat. So in this case, the energy is from nuclear power. We can burn coal, we can burn natural gas. All of these things are used to do this process. So this process almost needs to be committed to memory. So many countries use nuclear energy as a source of electricity, and France uses about 80% of their electricity comes from nuclear power, whereas the United States, less than 20% of our energy comes from nuclear power. One really great thing is that it doesn't pollute. It releases steam into the air, which is not really deadly. However, splitting the atoms creates dangerous radioactive waste, and it remains dangerous for hundreds to thousands of years. And so the big question is, what do we do with that waste? And I believe in Minnesota we have 2 areas where we store this radioactive waste from nuclear power plants.